Good morning, Caterpillar. We are Team 3, and I'm Megan Johnson.
I'm Thomas Wee.
I'm Jamie Pascal.
And I'm Tierney Stein.
We're going to start with a company overview and then state the problem, as well as explain our model and demonstrate it, and then we'll follow up with our recommendations. As you know, Caterpillar has nearly 300 operations in 40 countries, and over half of the sales and revenue are coming from outside of the United States. And we also included Caterpillar's mission statement.
So the problem we're given is that dealers are currently making transportation mode decisions based on rules of thumb they independently devise. Caterpillar is often unaware if these decisions are based on sound analysis or if they are consistent across various dealers. Now, Jamie will discuss and explain the model we've developed.
So our model can be viewed on Microsoft Excel, and for a brief overview, the way it works is that the dealer can input the product number and the store number that they plan to order. Then the information about that product will appear at the top of the screen, and 4 different transportation options are shown and compared with one another. The parameters that we used in this model include lead time, transportation cost, interest, carrying cost, service level, and demand. We made several calculations to get to the unit cost per order of each mode of transportation, surface and air. Here we have the surface mode shown, but we performed the same calculations for air per unit. This slide shows how we came to these costs. Other calculations we made include the minimum service level quantity required per year and the minimum number of orders required per year using EOQ, and finally the volume of each part. Now we're going to demonstrate how our model works. So I'm going to choose store number 66 and product number 132. So as you can see, above we have information about the product, such as quantity on hand, part description, monthly forecast, and so on. And then down here, we can see that there's different pairs of transportation modes. So for example, surface plus surface. The first mode is the mode of transportation from Caterpillar to the dealer, and the second is from dealer to the store. And then down here, we have comparisons between each of those 4 pairs of modes. So this graph shows the lead time by transportation option, and this one shows the transportation cost per unit. The dealer can use this model to choose which transportation modes are best. However, we realize that there are limitations, that one direct answer cannot be derived from this model. There are many things to consider, but we laid out these factors easily so that Caterpillar and the dealers can understand the necessary inputs. Now, Thomas will discuss the 2 transportation modes.
For the time value of the transportation mode, the 2 main modes discussed in this case study are shipping via air and shipping via ground. If one of Caterpillar's dealers required an item immediately, shipping via air would be appropriate since it is considerably quicker than ground transportation. In addition, shipping via air offers a larger range of destinations. In other words, air shippers transport freight to global destinations that trucks alone cannot reach. However, there will be a high expense with shipping those goods. When shipping via ground, Caterpillar can ship almost anything, regardless of how big it is. This saves Caterpillar time and money when they ship their heavy machinery to a regional dealer. All that aside, there's a big issue with shipping only on ground as well. Trucks cannot always get from point A to point B. Road closures, accidents, and detours are unexpected, but they occur with some regularity, causing delays for truck shipments. Now moving on to the impacts of shipping full versus less than full containers, there are benefits and costs to both decisions. A benefit of shipping in a full container is that it is cheaper than shipping in LCL. This is because in several cases, many international import fees are fixed, which means Caterpillar would be charged the same fees regardless of the size of the container. Also, FCLs get delivered more quickly than LCLs. When a full container shipment arrives at port, it's unloaded from the vessel and delivered to the dealer. It's more complicated for LCL shipments. Someone has to consolidate different shipments, process multiple documents per container, and then sort goods for each dealer. Every point could be a delay. In other words, at origin, the shipment has to be grounded together to fill a container. At destination, there's a greater risk of examination by customs, and if one container gets flagged, each shipment has to be checked and can cause days of delays. Also, because of this, shipping in LCL can increase the risk of damaged goods. If Caterpillar ships in LCL, it has no control over the cargo that will be loaded in the same container of its goods, which could be potentially hazardous to Caterpillar's products. Additionally, given the extra complexity of going to multiple places, there's a greater risk that Caterpillar's cargo may get misplaced or lost. That said, shipping in LCL has its benefits as well. For instance, LCL allows dealers to handle smaller volumes so they can keep their inventory lean. This makes sense if dealers do not have the money or space to accommodate a full container at their warehouse. This also results in a free up of cash flow for other purchases. Now, Meg will talk about how frequent Caterpillar should analyze a model.
In order to ensure the best decisions are being made, we recommend the frequency of model analysis to be based off changes to the order, forecast updates, and the service level. Order changes, such as a new order size, could affect lead time, cost, and transportation method based off the new quantity and is therefore important to perform a new model analysis. This will ensure the new info is being considered to provide the best optimal solution and the data will more accurately reflect Caterpillar's current activities. As parameters such as dealer financials or working capital change, new revisions are required. Finally, we recommend parts with higher service levels should be analyzed more frequently to ensure the service level is maintained. Service disruptions by changing the delivery mode may occur when evaluating alternative methods of transportation. In order to deal with any disruptions in service, we recommend taking into account the lead time, service level, demand forecast, and its deviation. Because these factors all affect service, our model displays this information for each part by its store in order to include it into the decision making. Identifying the trade-off between cost and lead time may factor into changing the delivery mode. For example, if the model shows a lower cost for air but a very large lead time, this could delay a guaranteed shipment and therefore disrupt the ability to maintain its service level. You would then proceed to look at the service level along with its forecast and deviation to better guide this decision. A major benefit of our model is the ability to have a view of all this information regarding service in one place in order to prioritize what is important for that specific order, product, or customer. Tierney will now tell you about managing network constraints.
Thanks, Meg. Managing a complex global supply chain network is not a simple feat considering over half of Caterpillar's sales are from outside the U.S. For this reason, there are many constraints on this network, and it is difficult to make adjustments when a large number of parts change delivery mode. Some of these constraints include cost, supply, demand, and geography. They need to meet the demand for their customers by keeping service levels high and having necessary inventory on hand. Additionally, different networks have different geographical regions. For example, surface transportation might not be possible in all places, and some regions are supplied by remote facilities, which can lead to significant lead time increases. These are all considerations that should be made separately for each network, which creates difficulty in standardizing a model, which is why we built flexibility into our model so that it can be applied to all regions of the world, not just Latin America. For this reason, we made sure that all important information for each part at each specific store was quickly and easily retrievable so that decisions could be made fast but also more predictable by Caterpillar. Moving on, currently the dealers maintain their inventories and order replenishments through Caterpillar's distribution centers. Sometimes the cost may be lower for the dealer to ship one way, but they have to account for variable lead times, inventory control parameters, and costs of carrying high levels of inventory. All of these factors play into the dealer's decision, which is very time-consuming. By using our model, the dealers can save time, but also make more educated decisions on how to order their inventory through clearer rules. Additionally, through this increased visibility, collaboration will be enhanced, which relates to one of the major principles of Caterpillar teamwork. This model has the ability to be updated to meet the dealer's preferences so that together they can produce better results than they could alone, which benefits Caterpillar as a whole, themselves, and their customers. Also, this will help the dealers manage their assets more effectively, leading to less working capital being tied up during lengthy travel, increase customer satisfaction, and increase their operating margins. All these things will benefit the dealer greatly, which will help convince the dealer of the need and appropriateness of this model. For Caterpillar, the transparency through a single model can help improve their policies regarding inventory and transportation in many ways. To align their supply chain better, this model will reduce the bullwhip effect by sharing the same information with Caterpillar and its dealers and allowing Caterpillar to understand the basis for their dealers' decisions, which they currently cannot predict. Caterpillar can then analyze these decisions to make improvements in transportation costs, efficiency of the supply chain, and operating performance. For example, Caterpillar can create strategies for optimizing slow versus fast-moving parts. By working together to create transparency and visibility in the model, they can increase efficiency and create more value for all parties involved. With that, we conclude our presentation and we thank you for your time.